so that is good news. So the thing is, when I try 100,000, I got negative, and then when I try 200, I get positive. So it's in between 100 and 200. So the next thing I'll try is 150,123. Okay, so calculate 150,123, and then I got 161 positive again, 0.182 times 10 to the power 6. And then, okay, it's still positive. I'm in good range, but it's getting low. So the next one I'm going to calculate is I'm going to try 125,123. Okay, why? Because 150 and 100. Okay, so I'm focusing on this value now and this value over here. Okay, so I'm trying 125. So calculate 125,123. Now I'm getting a smaller number now, 3.85 times 10 to the power 6. Okay, so next I'm going to use 115,123. Okay, so I'm going to calculate 115,123, and I get now I get minus, so I get minus 48.54 times 48. Okay, so we know that the answer is between 125 and 115. Okay, so the next one I'm going to calculate is I'm going to try 120. So calculate 120, 123, and I get minus 22.991 times 10 to the power 6. So now we are getting better. So it's between 125 and 120. So I'm going to try 123, 123. So I'm going to calculate 123, 123, and it's equal. I have minus 7.046 times 10 to the power 6. So now it's between 123 and 124. So I use 124. Okay, calculate 124, 123. And now my value is getting smaller. It's minus 1.6245 times 10 to the power 6. Okay, so it's between 124 and 125. So now we are very sure the value is between, so the value we are going to calculate is our A. Okay, is between 124 and 125, 123. So the next value I'm going to calculate is 124,500. Okay, so calculate 124,500. So now I have a positive. Okay, so I have a positive 1.106 times 10 to the power 6. Okay, so now it's between 124,500 and 124,000. So I'm going to now try 124,250. Okay, calculate 124,250. So I get minus, very small now, minus 260.581 times 10 to the power 3. So now it's between here. So I'm going to try 124,350. Okay, so calculate 124,350. So it's now 285, okay, 0.96 times 10 to the power 3. Okay, so I'm going to try 124,300. Okay, so calculate 124,300. So I get 12.622 times 10 to the power 3. So I can go lower. Okay, so now it's in between 124,250 and is with 124,30. So I'm going to try 124. I'm going to try 275. So calculate 124,275. Okay, 124,275. The answer is equal to minus 123.997 times 10 to the power 3. So I think I went too small. So I'm going to try 124290. Let's calculate 124290 is equal to minus 42. It's getting better. Okay, so the next one I'm going to try is 124295. Okay, so calculate 124295. And it's getting smaller though. And then finally, so I know it's in between 124295 and 1243. So I'm going to go 124297. Okay, so calculate 124297. So now the value is 3.773 times 10 to the power 3. And if you want to go any further, 124298. Now is equal to, now it's positive 1.691 times 10 to the power 3. So you quote your value as P due to eccentric loading is equal to 124.298 times 10 to the power 3 Newton, which is larger than the P-centric, which is equal to 83 point what? We calculate 83 point, what was it? 83.506. 83.506 times 10 to the power 3 Newton. So this value that we use is valid, okay? Because the P-eccentric is just way too high. And now this P-eccentric that we calculate is based on stress max is equal to 414 times 10 to the power 6 Pascal. Okay. So in your homework tomorrow, if you see trial and error, okay, it's exactly like using your CALC button on your calculator. And as I mentioned, if we go to Avenue to Learn over here, right, is how to use Cal for trial and error. You follow what they do, and it's not difficult at all. Okay. And as I say, you are expected to know how to do this in your all your term tests and your final exam based on trial and error. Okay, right. If you have any issue, just contact me. Okay, then I will show you on video again. Okay, where I'm doing it live with you one by one. I can't do it today because I don't have a camera with me, unfortunately. Okay, right. So now I want to deal with another question. But before I deal with another question, right? So this is based on the example we have done. Okay, is based on eccentric loading, and the most important thing is this. Okay, because we have gone through a lot. The most important thing that I want to highlight is this. Okay, when the term buckle is used, what does it mean? When the term yield is used, what does it actually mean? Okay, so I want you to capture the essence of it. Okay, right. So the next problem that I want to do is over here. Okay, and this problem has a lot of layers. Okay, some of you have taken 2Q with me, and you're aware that I don't do easy examples. I always pick the worst. Okay. Okay. So let's look at this example over here. The steel column support the two centric loads. Okay. It is assumed to be pin at the top and fixed at the bottom and fully braced against buckling about the YY axis. Okay. Determine the maximum deflection of the column and the maximum stress in the column. Okay. So given that E, right, the Young's modulus of steel, we are given it to be 200 times 10 to the power 9 Pascal. And then our stress yield is equal to 360 times 10 to the power 6 Pascal. Okay. This problem is very unique in a sense that it tells us, okay, it's unique because you have two different loads over here. Okay. And we also have two different E values. Okay. In the actual calculation, you only need one E value and not two. Okay. That's the reason why I picked this problem. Now, in the first part of the context, okay, it states that fully braced against buckling about the YY axis. What does this actually mean? Okay. Now, if you look at, if we look at this diagram over here, you somehow need to relate the cross-sectional view to the front view over here. Okay. So we know that this is your Y. Okay. And then over here, this is your Z. And over here, this is rotation in the X. Right? You can see that. Okay. So getting the transformation right is important. Then you will know what does it mean that is fully braced against buckling in the YY axis. Then you fully understand that concept. What does it actually mean? Okay. Right. Okay. Now, the first thing that we're going to do, right? We want to find out what does it mean by the YY axis. Okay. So now we do simple stuff first. Okay. So if we were to focus on our YZ plane, and YZ plane is also known as buckling about the x-axis. Okay, so we know that this is our y and this is our z, and we are aware that this is under eccentric loading, right? And I'm going to sketch. Do not memorize, okay? My course, if you memorize, you're in trouble. You have to analyze, okay? You cannot memorize. So in our theory, we only have a single P. And then we also have a single E. And this over here, is there okay, this over here is inducing a moment